Hello everyone, welcome to Statistic and Probability in a Data Analytics. So today's session will be moving towards to the understanding with the additive theorem. So if you remember the previous session, we are going with the things where we understand that how we need to use it and how we need to use the Bayes theorem. Now we are moving to the another useful theorem is your additive theorem. So before moving to going how need to use it, let's understand what you mean by that. So basically this theorem was state with the two things, that is A and B, and two mutual exclusive. So as we know that in our normal maths, right, just move to the your school life where we learn, or the college life in a standard 11 and 12, we learn the things in a mathematics, that is set concept, right? SET, set concept. So there the things we learned it, that is union, we call union, and we learn one more, that is intersection, right? So union, EON, union, and we learn a intersection concept as well. Intersection. Intersection. So there is two symbols on that. For union we use U symbol, for intersection we use reverse U symbol, right? And except these things we used a bar also, like for when you want it for the extra things, and also we use a bar like this. So if you observe here, we use the same thing here, intersections here, right? Union means union all the particular part, intersection means the mean of the part, like which one we needed. So the same set concept we used in here as well, where we call union it's work like a or, and your intersection is work like a and. So that is like your ways how we need to add on that. So the first one, which is awkward, that is it is taken a two statement A on B. Already it's taken a two mutual exclusive. This is your two mutual exclusive, your A, and then you have one more mutual exclusive, that is B. So this two your mutual exclusive. I just give you the short form on that, M dot X. So this 2 will be the starting part. It's a compulsory thing, because with that only we need to work on the other part, like then only the formula will satisfy for the additive theorem. So here what happened, after that we are going to the things where we call P of C, probability of A union B equals to PA plus. So here it's intersection where this part will be there and this part. So this is your main thing, like if you want to find out A intersection B, you need this part, because this is my intersection part, right? This is my intersection part, one, this particular area only my intersection. And suppose you need a union, union means your this full part, this full first circle, this is a 1. So you can take as like if you wanted A union B, so this is the full part. And if you want here also, there also AB is there, right? So here this is a full A, this is a full B, and if you want A union B, you need to go with the full thing. This is the full thing you need to go if you wanted A union B. So this will be your A union B. And if you want to go with A intersection B, you need to take only this particular area. So I just put a color on that. So this is the particular area where you need to go with the A intersection B. So this is how you need to find A union B, A intersection B, because that we need to take it, because whenever we need to find the theorem, we'll use this particular. Now depend upon the example, depend upon your problem statement, how need to go with that. If your problem want union B, you need to find the union B. If your problem statement want your intersection A intersection B, you can go with A intersection B. See, these two names are given by us. Names are anything, but this is one the sets. So remember that in your mind, and you can go ahead with the normal. So you know that there is a example like cards example, right? You can take as a problem statement on that card. If you draw it in that particular probability, so how many time possibilities are there, you will get a joker card, so that you can find out. So for that we need a formula, like you have total how many cards you have, 52 cards. In that, how many time probability is there, like you can get a joker card, because there is so many cards are there, joker, king, queen, then you have your a card. So those things are, you have a card, so the probability you need to find, you need to go at that. For that we need a formulas, right? The formula is built nothing but it's going with the probability, like your P of. Now this is the main thing. When it comes to the card, what happened, what you want, because you need to choose you want a union B or A intersection B. For the card, I need to take the 52 all the card, because I need to find out of the 52 cards and one like probability of or possibility of my joker card to get. So for that I need a union B, because if this is a card A and B, I need all the cards. So that's why here you need to go with your A union B, right? A union B, and then equals to the formula. How you need to get it? Now we need to find from the two set the P of A, from the P of A, so P of A, and then we are going with the P of B. So how many set you will go? You have to go with the P of B as well. So this is how P of B. So this is how you need to use your additive theorem. So additive theorem basically it's depend upon your sets values. In that you need to choose your union, intersection, then you have to going with the other things to use that. So this is what your additive theorem used in your statistic and a probability in a data analysis to help to find out the values on that.